Okay, so to continue, uh, as the previous discussion states, this particular code here is now true, and so we will run the following statements. Right? So we say that our minimum number is now the value of in, which takes index 2, and so that is 44. Right? So 44 is now the new minimum. And so if you look at it, our swap method here states that we take two parameters, right? And if you check our code for swap method, you will see that the method will take two parameters as well, or two arguments, right? And so we just name it 1 and 2. If you look at the code of the algorithm itself or selection sort itself, it will take out as the first parameter, and out here is 0, right? Because we will transfer 44 to index 0, right? And also, if you look at the second parameter, it takes the value of min, which is the value of in, right? So that means that uh, we will transfer 77 right there, right? In other words, we will swap 44 and 77 because 44 is the number that should be in the index 0 because it's the smallest number of the given sample data items, right? So if you look at swap method, right, it says that you take out here, which is 0, right? If we simplify this one, okay. So let me do this only to simplify everything. So the value of out is 0, okay, as you can see here. And then our new min is the value of in, which is 2, right? Okay. Now, if you check this one, remember this is 1 and this is 2, right? If you check the following statements, we have a statement that says the index 1 of array A should be stored in our temporary variable called temp, right? So the index of 0, again here, is 77. And so this means that we will store 77 here in the temporary variable called temp. The next instruction also says that the index of 2, which is in this case is index 2, right, will be and should be stored in 1 or index 0 because this is our uh, this particular argument is the argument that we've thrown from the parameter called 1, right? And I hope it's not confusing because you have already had previous experiences with parameters, right? So the value of this particular index 1, which refers to this one, okay, is going to be replaced with the value of this particular index, which in this case is 2, right? And this is going to be 44, right? So that means this particular index will be replaced with 44, right? And this particular number here is going to be removed because we swapped it. So you have two cases here. Where is number 77 and what do we put here? That is the reason why 77 here is temporarily stored in a temporary variable called temp, right? So what do we do with it? We proceed to the next statement. It says the value of temp will be transferred to index 2. What is 2? Variable as in word TWO or 2. That is the second argument, 2. Right? So that means 77 is going to be placed in index 2. 0, 1, 2. And there you have it. We swapped uh, the two indexes, the value of two indexes, because we realized 44 is smaller than 77, right? Now, if you go back to the code, because we're done with swapping, this will again, the control of if statement is now over, and so it will again proceed to the control of our inner loop, right? So according to inner loop, it will increment all over. This will now become 3. And is 3 less than 5? It is, and so it will again run this particular code, right? Okay. In this particular code, we say A index in, and index in is now 3. That means 0, 1, 2, 3, 55, right? So we say 55. Now, it checks the value of min, right? This is the part where I said min did not really change uh, uh, along all the way, because we kind of changed min a while back with the value of in here, right? It does not really change that way, because the value of min will stay the same as how it retains the value of variable out a while ago, right? Now, from the table, min will remain 0, okay? Because we want to check, we have specified a while back min as in the index 0, because we want to make sure that this particular index contains the smallest number, right? We do not say a while ago min was changed to 2, right? We do not want that, right? Because we want our first index to contain the smallest number of them all. So min did not really change along the way a while back. It will only change only in this particular code. In programming, it will become a local variable. It will become a local variable in that sense, right? So its effectiveness is only here, right? It's only changed in this particular part. As long as if is done with its job, and as long as the control is given back to for loop, min will again go back to 0. Okay? Now, in is now changed to 3, and 3 is again 0, 1, 2, 3, 55, right? So that simply means is 55 less than, and since min is again 0, that means now 44, because the index 0 is now 44, right? So it will mean is 55 less than 44, right? Of course, that's untrue. Okay? That is untrue. That is false. And so we will exit again and increment in again into 4. It will now proceed to 0, 1, 2, 3, 4, 22, right? And so if we go straight with with the meaning of the code, just like the previous discussion, it will simply say, okay, if 22 is less than 44, then run this one. Obviously, this is true, right? Obviously, this is true, okay? And then we swap it again, right? We get min as in the value of in, and so uh, we get this one. This will become the new minimum number, and so from the value or from the method swap, it will take out, right, and replace it with min, right? In other words, if we go back to swap, this will again be, okay, take out, our out is still 0, right? And then take min, right? The new value of min, which is in this case is the value of in. This one, 4, right? So this now become 4, right? Meaning your one here is 44, and then your index 4 here, which is the index, your index 4 in here, which has a value of 22, right? We put it this way. Okay. And then we exchange both, right? This will become 22, this will become 44, right? And so we're done with swapping. We go out, in will become 5, right? And is 5 less than 5? Oops, that's not true. Then your inner loop is now done with its job. And that's the reason why we did not deduct 1, to make sure that we will reach this particular point, because we want to make sure we are we want to make sure that we are going to go through along all the data items and compare it with index 0. So as you can see, our minimum is always going to be returning to 0, as in this one, people, and in, by the way, has now changed to 4. We want to make sure that mean in here is will remain 0, because we want to make sure that the first index, right, index 0, always will contain the most the smallest number of them all, right? And so as you can see, we are sure that index 0 is now the smallest data item compared to all the given data items. So we can now proceed to the next index. And hence, we will be able to do that. And since, because we are now done with inner loop, of course, inner loop will return the control back to outer loop, right? And so outer loop will now become 1. And so min will now become 1, right? And that means, because we are sure that this is now the smallest of all number, we will then proceed with the next smallest number, right? So out is now 1, min is now 1. And then same story, we will interpret this index as the smallest number. In other words, we will leave this alone because we are now sure this is the smallest number, right? And that is how a selection sort works.